blue-green algae calibration without secondary standard. The blue-green algae fluorometers use the same principles but different wavelengths of light to detect different chemicals in the sample. The freshwater fluorometer emits orange light and detects the red light emitted by the pigment phycocyanin. The marine fluorometer emits green light and detects the orange light emitted by the pigment phycoerythrin. Monitoring in vivo, that is, an active biological condition, is subject to a great deal of variability. The fluorescent properties of a cyanobacterial population in a body of water can change with the health of the organisms, temperature, and exposure to light, even while the concentration remains the same. This makes in vivo data useful for trending or for correlating relative measurements to more quantitative values. The readings can be reported as a scaled voltage from 0 to 5 volts or as a concentration from 0 to 2 million cells per milliliter. Maintenance. The only maintenance required for the fluorometers is to keep them clean. As optical sensors, it is very important to give them a clear field of view into the water sample. Before and after each deployment, use a soft brush and mild soap to remove dirt and debris from all of the sensors. Rinse with clean, fresh water. Do not use organic solvents such as methanol or acetone to clean the sensor. These chemicals will damage the plastic components of the sensor. Calibration. Establish a connection to the sonde with Hydrus 3LT. Click the button labeled Operate Sonde. When the sonde finishes its initialization, click the Calibration tab. Then click the Phycocyanin cells per milliliter tab or Phycoerythrin cells per liter tab. You will see a picture of the fluorometer as well as the current cells per liter, the date and time, the current temperature, and the voltage reading of the sensor. Begin with a clean and dry sonde. Attach the calibration cup and fill it to the threads with sample water that has been filtered of all blue-green algae or optionally clean fresh water. Wait for 1 minute for the readings to stabilize. Type 0 into the box and click Calibrate. A calibration successful message will appear. At this point, record the voltage reading. Empty the storage cup and rinse the sensors. Dry the sensors and attach the storage cup. Fill the cup to the threads with a fresh sample from the deployment site. Wait 1 minute for the readings to stabilize. Record the voltage reading. Have an extraction performed on the sample to find the true concentration. When the results of the extraction are known, the chlorophyll A sensor is recalibrated using this value. The secondary calibration will be done under the phycocyanin volts tab or the phycoerythrin volts tab. Type 0 into the box labeled phycocyanin cells per milliliter or phycoerythrin cells per milliliter. Type the voltage from the original 0-point calibration in the box labeled phycocyanin volts or phycoerythrin volts. Click the Calibrate button. A calibration successful message will appear. Now type the extracted value into the box labeled phycocyanin cells per milliliter or phycoerythrin cells per milliliter. Type the voltage recorded from the sample before it was extracted into the box labeled phycocyanin volts or phycoerythrin volts. Click the Calibrate button. A calibration successful message will appear. These concentrations and voltages can be used for future calibrations of this specific blue-green algae sensor. The blue-green algae sensor is now calibrated.